Forming ionic compounds and naming really goes hand in hand. What do I mean by that? So when I say the word sodium chloride, what comes to mind? I hope you think, oh, that's table salt, because you would be correct. So sodium chloride is the name of the compound, but how do we figure out what the chemical formula for sodium chloride is? Well, this goes into ions. So first off, we've got ionic compounds and we have covalent compounds. If you pull up your periodic table, you're going to see the periodic table is once again organized so beautifully for us as chemists to use them. So in the middle of the periodic table, on the left-hand side, you have your cations, and on the right-hand side, you have your anions. So what that means is things that are anions and cations, they're going to want to react together because one's positive and one's negative, and so opposites attract. But remember how I said those pesky guys in the middle that don't really want to form ionic compounds? Well, that's because they typically want to form covalent compounds. So look for that stair step on your periodic table. On the periodic table, you've got the stair step, and what the stair step is doing is it's separating your metals from your nonmetals. And if you look at this line, what that's going to do is tell you is if you have two molecules that are bound together, and one of them is on one side of the stair step and the other is on the other side of the stair step, then they are going to form an ionic bond. But if they were both on one side of the staircase, then they are going to form a covalent bond. And that's because ionic bonds are formed when opposites attract. And so in this case, you've got a cation and an anion, or another way of thinking that is a metal plus a nonmetal. And so those are the two ways of figuring out whether or not you have an ionic bond or a covalent bond. Sodium, group 1, chlorine, group 7. So find those two. And then we've already figured out how to predict the charges of each of them. So we have sodium, and then we have chlorine. Okay, we'll find out in a minute what the IDE means. So sodium is in group 1. That means it forms a +1 ion. Chlorine is in group 7, so it forms a -1 ion. And so with these two molecules, you'll notice one is a positive, it's a cation. It's also a metal. I should have written those. Oh, no, I wrote it right. So you'll have a metal and a cation, which is your sodium, and then your chlorine is your nonmetal, which is our anion. Okay, so in this case, when these two react, they're going to form an ionic bond. So there's a couple ways to do this. You could just think about it logically, meaning if sodium reacts with chlorine and they both have a charge of 1, one's positive and one's negative, but they have a charge of 1, then they'll react 1 to 1. Or you can do what I'm going to tell you many times throughout this class, is you're going to want to cross the charge. What that means is you take this charge, ignore whether it's positive or negative. The positives are always written first. Always, always, always. Okay? And then you take this and you're going to cross them, meaning whatever the number is going to become a subscript on the other one. So this is a understood 1, understood 1. Those are going to come down. You're going to cross the charges, making it look like sodium with the 1 that was the charge on the chlorine, and chlorine, which was the 1 from the sodium. Now we don't write 1s though, so it's really just going to be NaCl. But this is how a simple way of trying to figure out what is the molecular formula, or the chemical formula rather, for this compound. And so it is sodium chloride, and it is put together with an ionic bond. Let's try another one. Next up, we have magnesium bromide. Now before we go anywhere, let me stop you and notice two things. Once again, we've already mentioned that the cation goes first and then the anion. And also something else I want you to notice is that the capital M, the M is not capitalized, neither is the B. You don't capitalize the names of chemical formulas. All right, so magnesium bromide. First off, we have to decide, is this an ionic compound or a covalent compound? We know it's ionic because magnesium is a cation, bromide is an anion, or metal, nonmetal. Okay, so now we find magnesium on our periodic table, and we found bromine. Once again, we got the "ide." Still, we'll mention that in a minute. So magnesium is in the second group, so it's going to have a 2+ charge. Bromine is in group 7, so it has a -1 charge. Now let's cross the charges and figure out what compound is formed. So the 2+, the 2 comes as a subscript for the bromine. The 1 becomes a subscript for magnesium. So it's Mg1, Br2. But we don't write the ones, so it's just MgBr2. And that's the chemical formula for magnesium bromide. All right, so now you may be asking, okay, fine, what does the IDE stand for then? What we do is anytime when we're naming, we're just going to replace the INE prefix from chlorine, we're going to replace it with an IDE. And so these are what's called a type 1 ion. And anytime you're naming type 1 ions, you just always do this. The ending gets changed, so it ends in an IDE. So oxygen's the weird one, oxide, fluoride, bromide, all of those anion names are going to get changed so that they end in IDE. They're called type 1 ions because they form only one charge. Meaning, your cations here, magnesium only forms a 2+. It doesn't form a 3+, it doesn't form anything else. It just forms one type of charge. So if you have things like copper, chromium, manganese, iron, those things are going to have more than one charge. So those would be a type 2 ion. All right, and so these will form multiple possible charges. All right, and so in looking at this, these type 2s, you might be saying, well, how do I tell the difference between a type 1 and a type 2? All right, so most of your transition metals, those are going to be type 2. There's a couple of exceptions, and so we're going to have a list of ones that you should be very well aware of and know. But basically, group 1, group 2, those are always type 1. They are always +1, +2, okay? Your aluminum, +3. Okay, your anions are almost always just gonna, the type 1 is describing your cation, not your anion. Okay, they're just gonna have one possible ion form. Okay, so this is a type 1, a type 2 ion now. It is gonna look slightly different in the name, but we're gonna treat them the same way for how in the world do we depict which one is gonna be formed. Next up is iron 3 oxide. Now you may be asking, hey you, what's up with this Roman numeral? Well, that Roman numeral is how we know that is a type 2 ion. The other way we can know is iron. If you go look at it on the periodic table, it is in the transition metals, which means it's most likely going to have more than one charge. Not always true, but most likely. But we still treat this the same way. So meaning iron, we know it's iron, and then oxide, what element is that? Oxygen. Now, oxygen doesn't have more than one charge, so we know it's 2 negative. Iron, on the other hand, has more than one charge. So how do we know it's charged? It's what is written in the Roman numeral. So if it says iron 3, your charge is 3. Now, is it plus or negative? What do you think? If we know it's a cation, it's positive. Your cations are written first. So iron 3 oxide. All right, so now, what do we do with this? Let's form the compound. Cross those charges. Bring this one down, and this one down, leaving us with Fe2O3. And that is the chemical formula for iron 3 oxide. All right, so we've done a type 1 and we've done a type 2. Next up is going to be covalent compounds. Those are different in how they are named, and so we'll do those in a different video.